Hi everybody, my name is Bhavishya, and in this lecture we will see a new topology where we will introduce two ABR in one topology. In the previous all topologies we have just saw ABR connected with different areas. One ABR connected to different areas like area 0 connected to a backbone area, then connected to a non-backbone area, like that. But we have not seen yet two ABRs in one frame, right? So let's begin. So for this, we have router 1, we have router 3, and then we have router 2. Router 1 and router 2 is connected to each other, and the network here is 12.0.0.0, right? Then we have R3 connected to R2 with network 23.0.0.0, right? Yeah. Then we have R2 connected to R4 with network 24.0.0.0, right? Then we have R4 connected to R5. Then we have connected with network 45.45.0.0.0. R4 connected to R6 with network 46.0.0.0. And now when it comes to area, so this particular area is area 1. Then this particular area, then this particular area, this is our area 0, our backbone area. Then we have this, so for that, and this is our area 2. Okay, so as you can see that we have two ABR in the situation. We have two ABRs. The very first is R2, and then we have R4. Right, now the game is, we change the color for that. When R2 will generate the network summary LSA for, let's suppose, area 0, so the network they are going to propagate will be 12.0.0.0, right? And 20 and 23.0.0.0, right? This is what it will propagate. And the originator ID, or you say the router ID for this particular, will be its own router ID, right? Which is 2.2.2.2. Assuming that R1 is having router ID, or you can say loop packet address 1.1.1, up to R6 having 6.6.6.6, right? So when R2 is propagating network summary LSA about this, and this is what it is propagating, right? Networks, this is the originator ID, or you can say router ID. But when R2 is further sending it to R4. When R4 is propagating it to its own area 2, then it changes its own router ID from 2.2.2 from 2.2.2 to 4.4.4.4. Let me revise of what I said. The rule says that whenever a ABR whenever a ABR receives and network summary LSA before forwarding it to the corresponding area, it changes its own router ID. So in this case, when it receives an router ID, when it receives a network summary LSA, it changed the value of the router ID to its own. So there it was its own router ID. So there was no big thing. It was there was not a big thing. It was not a big thing. But when it sends it to this particular area, this corresponding area 2, it changes its own router ID from this 2.2.2 to 4.4.4. Right? Yes. Now, the second thing, that is, it's a condition that one follows, which is, let me erase it. The condition is that, and this condition is a very strict requirement. The requirement is, as you can see, we have one backbone area and we have two non-backbone area, right? So for the non-backbone area to exist in a topology in a perfect condition, the strict requirement is that there has to be minimum one router connected to non-backbone area of backbone area. As you can see here in this topology, R5 and R6 are not present in the backbone area, but it is connected directly to an backbone area router. Let's suppose if I add a router here, let's suppose this is my R7. So the existence of R7 will be accurate here, as minimum one router here is connected to backbone area, right? So this is a strict requirement. So let me revise of what we have learned. Let me scroll. Okay, so the very first thing is that whenever ABR receives network summary LSA before it forwards to corresponding area, before it's forwards to corresponding area, it changes its router ID, right? Yes, this is the very first rule. The second is, and it's a strict one, for non-backbone area, that is, there has to be minimum one router connected to our non-backbone area, the one which is of backbone area. Minimum one. This is the requirement for non-backbone area to exist in the whole topology perfectly. So these are the concepts. I'll see you in the next lecture with a lab on this concept. I hope you enjoyed. See you in the next one.